So lightweight entities is nothing but it will be having small structure. Okay, the structure will be very small. And then task is defined as task. Next is task. Task is defined as embedded program computational unit that runs on a CPU under the state control of kernel of an OS. So task, complete task. Okay, so first task, next process, and then thread. So main task. Okay, main activities in your embedded system will be called as a task. Okay, or application you can call it as a task, and the application you'll be having so many process. For example, you take fridge itself. Okay, so fridge is a main task. What it will be cooling the cooling system. Okay, cooling system. So adala under that task you will be having so many process, like you can keep vegetables as well as you can make the water into ice. Okay, so இதெல்லாம் என்ன another format, another process. So அதுக்கு ஏத்தாப்புல the uh, process will be named. Okay, so under the process you will be having so many modules. Okay, these small programs altogether, all the modules altogether will be called as a process. Okay, that small module is nothing but your what is that, thread. Okay, so task, process, thread. So task is defined as the embedded program computational unit that runs on a CPU under the control of kernel of OS, operating system. So it also has a state, okay, which is defined by the running, blocking and finishing. Okay, running, blocked or finished. இந்த மூணு status தான் இருக்கும். But threadல பார்த்தீங்கன்னா you'll be having one more thing, that is start. Running, blocked or finished. இங்க வந்து start கிடையாது, running, blocked or finished. இந்த status மட்டும்தான் it will be provided by the operating system kernel. Okay, and then structure its data, object, resource and control block. Okay, so structure of the datas. Okay, and then object, resources and control block means what are the memory you are utilizing for executing that particular program, data available in that program, and then controlling of that particular block will be maintained by the operating system kernel. Okay, then next, task. So diagram given for task, multitask. So first task is created in the system. So while creating the system it will be idle, the task will be idle. Then your task will be ready for executing. Okay, so by providing some signal or message, and then it will be executing your program. Task programs will be executing. Okay, that is given as running. You can the executing program can be either blocked or you can complete the running program. Okay, so block panla, you can complete that process. Okay, so that's why you are given blocked next to the running. Okay, so if you are blocked means you are stopping the program to execute. Okay, that then after some time you can start to execute the program from where you left that program execution. Okay, so that is blocked. So blocked means nothing but it will go to the state of idle. Okay, it will not be running. So two state after block, that is it either goes to idle state or it will start to run from the place where it is left while executing. Okay, these are the two states after blocked. So while running the program, you will be attached with your kernel of operating system. While your program is idle, okay, task is idle, you will be detaching the task from the operating system kernel. Okay, you will not be having control by this operating system. So here, listen here. Again, here they given one more diagram for code, sending code to the output port. Okay, so program, running program. So task send card information is provided to the mailbox post with authentication request, okay, from the external device, then only you will be sending the mailbox post, that is task send card information to the other device. Okay, you can block that sending. Okay, while you are sending that card information, you can block. That means you are stop giving the send card information to other device. Okay, why you are blocking means you are waiting for the authentication message to the read out that task, okay, from the output side port. Okay, so after that you will be running. So after the blocked information, you will be receiving the authentication message from the other device, then it will be start to running the task. Okay, then task and task state. This is task ID. 1 minute. This is task and task state. So you'll be in the task, you will be having first task ID, task content. Under the task content, you will be including the program counter, stack pointer, CPU register, process status register. Okay, so program counter, stack pointer, CPU register, that is nothing but the context of task will be holding the address and data in this register. The status of the task will be maintained by the program counter, stack pointer, CPU register, and process status register. Okay, and then task priority. So the priority given for the task will be maintained in the task priority folder, and then task context initial. Okay, so this will be the structure of task control block, TCB. Okay, so under the task control TCB, you'll be having task ID, task content, context, task priority, and task context initial. Okay, the next, so pointer to a startup function. A function runs start a task from its address. A pointer to the context data structure. The structure includes the processor register and status token. Okay, so the structure of the structure of the task will be including the register. Okay, register of processor and as well as the status. Okay, and then a pointer to a new task object which will run next. So if a pointer pointed to the next new task, then your object of the function will be holding the next details, next task details. Okay, so a pointer to the stock of a previous task object. That means a pointer will be holding the previous task information also. Okay, while running the next task. The next semaphore. This is the semaphore. Ma'am. Ma'am. சரிங்க மேம்.
Good morning to all. என்ன ஆச்சு திடீர்னு? Very good morning. என்ன ஆச்சு திடீர்னு சிருஷ்டி?